So number 69, we have a shuttlecraft, and we've got Captain Janeway in an orbit, a circular orbit around a planet. What's the period of orbit, the speed of the spacecraft? And so solving that one, pretty straightforward for A, circular orbits. Centripetal force, in this case I'm using 4 pi squared r over t squared, since we're trying to find the period, equals the gravitational force. Mass of the shuttle cancels out. We can solve for the period, plugging in our numbers, and doing a little bit of math. We get the period is 21,500 seconds. What's the velocity? Well, just using 2 pi r over t, you could also go back and use the centripetal acceleration ones. You'll discover that her velocity is about 12,300 meters per second. In C, she briefly fires a forward-pointing thruster, reducing her speed by 2%. Just then, what's the new speed? That one's easy. Just taking 98% of the old one gives us about 12,000 meters per second. D, what's her kinetic energy at that point? Well, just 1/2 mv squared. Plugging in our numbers, we'll get that. What's her gravitational potential energy? Well, she's still at the same radius she was before, so we can just plug in that radius we were given, and if we solve that, we get this. F, what's the total mechanical energy? Well, that's the sum of the kinetic and gravitational potential energy. Just adding those two numbers together gives us this. Still negative because of it's trapped in an orbit. G, what's the semi-major axes of that elliptical orbit now taken? And you might say, whoa, how do we jump from that? Well, again, don't forget the total energy of any orbit is given by this equation. In this case, we do know the total energy, and we can actually then plug that in and solve for A, the semi-major axes. If you do that, you'll discover the semi-major axis is now this. Please notice that is significantly less than the original radius of our circular orbit. H, what's the difference between the periods? Well, all right, now it gets a little bit more complex. Just using what we've written before, but solving it right away for this, or plugging in the radius. The new period is that. How does that differ from the original period? Well, the difference between these two, to take into more sig figs than were shown, gives you a difference of about 1,210 seconds. Which period has, or which orbit has the smaller period? The answer is this new elliptical orbit, substantially. All right, well, not substantially, but somewhat. Hopefully this makes sense. This problem had a lot of answers to solve, but it's a great one in terms of elliptical orbits. Good luck, have a good night, talk to you soon.